And here we go, 6.2. We're looking at the angles in standard position. And this time we're looking at all quadrants. So not just quadrant 1, but we're still following the rules that standard position gave us. Let's review those rules real quick. So we've got our initial arm starting on the positive x-axis. We're rotating positively counterclockwise until we get to our ending point, which is our terminal arm. That right there is our standard position. If we rotate counterclockwise, it's positive. If we rotate clockwise, that's going to be a negative angle. And then we're always centered at the origin for these. So let's get started. Point 2 and 3 is there. Let's reflect that about the y-axis. So then if we reflect about the y-axis, that means we're bringing it over here, and that gives us the same distance up. So it's going to be 3, but this time it's not going to be a 2, it's going to be a negative 2. We're going in the negative x direction. If we reflect that about the x-axis, it's coming down this way. That negative 2, it's straight underneath it, but now that 3 becomes a negative 3. And then reflect it one more time into quadrant 4, and we get the point directly below the 2 and directly across from the negative 3. And then to construct your understanding, we're doing the exact same thing, but this time we're doing it just in the general form. We're using x and y. So x and y, put here. And they're talking about standard position, so that means we're going to go from the origin to there. Now let's reflect that in the y-axis. Again, we're going to reflect over to here. But this time, instead of being an x and y, it's going to be a negative x and a positive y over there. Then we reflect it down across the x-axis. It's going to flip it down. We're going to be right over here. This time we got negative x in negative direction. And we're going down, so it's negative y there. And then we do the last one. And we flip it over to here. And that negative x becomes a positive x again. And we still have the negative y. And now the last thing they're asking us for is to do it in terms of r and theta. So that's back when we did in 6.1 that we talked about getting our x-coordinate from the cosine. So there's our r, and we did cosine of theta equals x over r. And then we multiplied the r up and over, so we said x equals r cos of theta. So that's r cos theta, comma. And the y, we did the exact same thing with sine, so it was r sine of theta. Now when we go into quadrant 2, so that's quadrant 1, going counterclockwise, we get to quadrant 2, the x value is negative. So it's now negative r cos theta, comma, r sine theta. In quadrant 3, we've got the same thing going on. The x is negative, so it's negative r cos theta, and then negative r sine theta in those coordinates for the x and the y. And finally, in quadrant 4, again, notice we're going counterclockwise around that, same as the rules for standard position. We've got a positive x, so it's r cos theta, and the y is r sine theta, but it's negative r sine theta. Looking at the 4 diagrams there on page 441, we've got quadrant 1, we've got a quadrant 2, a quadrant 3, and a quadrant 4 answer. And every one of those, notice what happens here. Notice how each of them, 35, 35, 35, and in this one as well, we're going to have a 35 degrees. So those are called our reference angles. They're the ones that are inside of the triangle if we draw our triangle to the x-axis. The reference angle is always between the terminal arm and the closest x-axis. let's write that down. Reference angle between terminal arm and closest x-axis. Always the x-axis, never, ever, ever the y-axis. So just by looking at the 35 degrees is not really standard position in the terms of it. We're always looking at starting at your positive x-axis and rotating to the terminal arm. That's called our principal angle. So that's when we start at the positive x-axis all the way to the terminal arm. Very similar to reference angle, but it's between positive x-axis and terminal arm. Both of these we're really always measuring in the positive counterclockwise direction. We'll get to doing more with the other ones later on. So in quadrant 1, notice that the reference angle equals the principal angle. It's the only time that's going to be the case. In the second quadrant, the principal angle we have to calculate if we know the reference angle in quadrant 2. So our principal angle is equal to the reference angle taken away from, well, we know if we would have went all the way to here, that would have been 180 degrees. So we go 180 degrees, come back that 35, we're coming back the reference angle. 180 degrees, take away the reference angle. In quadrant 3, we know that again, this is 180 to get us to there, but we want to go all the way to there. So I got to go with 180 plus that extra 35. Our principal angle in quadrant 3 is 180 degrees plus whatever the reference angle is. And now in quadrant 4. In quadrant 4, I know that going all the way to there is 360 degrees. But whoa, I went too far. How much too far did I go? 35 degrees too far. So my principal angle here is equal to 360 degrees all the way around. Take away that reference angle, whatever it be. So for these ones, the principal angle and reference angle in quadrant 1 are 35. In quadrant 2, the principal angle is equal to 180 degrees minus the 35 degrees, which is going to give us 145 degrees. I'll write it up there. In quadrant 3, our principal angle is 180 degrees plus the reference angle. Plus the 35 degrees. So quadrant 4 there, we've got the 360, and we take away that 35 degrees, which leaves us with 325 degrees there. So then why are we looking at these principal angles and reference angles? The reason being is that we can find the values of the principal angles, the trig ratios of principal angles, by looking at the reference angle, referring to a smaller angle, the angle inside our triangle. So if I give you the principal angle of 155 and you're looking inside, we're going to work backwards. We're going to say that the reference angle is equal to 180 minus our 155. Which gives us a reference angle of 25 degrees inside there. We're always looking at, if we drew a triangle down to the x-axis, what would be the value inside? In quadrant 3, we've got 235. But I know that it's 180 to here. 235 takes me further. So I'm going to be looking at going the 235 minus the 180, which will give me the inside of 55. Same thing that's going to apply into quadrant 4. But this time, we're looking at going all the way 360. Oh, too far. If I subtract the 310 off of it, That will bring me back to my reference angle inside. As you can see, 50 degrees inside there. In quadrant 1, x and y and r, using those, we've got our cosine, our sine, our tan. That was done in 6.1. Let's move on to the other 3 quadrants. I'm going to slightly change it up here from what your book did. Your book puts x and y. I'm going to say, no, let's write what the signs actually are. And let's put it as negative x comma y. So that I can quickly see that cosine is negative x over r. Cosine is going to be negative. Sine is y over r. That's going to be positive. Tan is going to be y over negative x. That's going to be negative. If you noticed in quadrant 1, all of them were positive. In quadrant 1, all of them are positive. Positive, positive, positive. In quadrant 2, though, the only one that's positive is sine. So sine is positive in quadrant 2. All of them were positive in quadrant 1. Now we get to quadrant 3. Again, I'm going to change it up here. I'm going to put negative x and negative y. So when we do our cosine, we've got negative x over positive r. R is the radius of the circle. R is always positive. Sine, negative y over r. That one's negative. That one's negative. Tan, however, is negative y over negative x, which gives us, oh, look at that. Those are going to cancel off. We're going to get y over x, positive. The only one that's positive is tangent in quadrant 3. So again, all of them were positive in quadrant 1. Sine was positive in quadrant 2. Tan was positive in quadrant 3. Let's move to quadrant 4. Again, changing it here. The x is positive direction. The y is negative. So when we look at that, we've got positive over positive. So that's a positive value. We've got negative over positive. That's a negative value. And then we've got negative over positive. That's a negative value. The only one that's positive here, cosine. Probably could have guessed it. Hasn't had its turn yet. Cosine. Again, in quadrant 1, all of them. In quadrant 2, sine. In quadrant 3, tan. Let's look at those. We've got C-A-S-T. Notice I started in quadrant 4 because that spells cast. So I'm going to refer to this, and this is referred to as the cast rule. Yeah, we start in quadrant 4. Or if you want, you could say add sugar to coffee or something like that, if that helps you remember. If you have to start in quadrant 1. But if we go like that, we've got the cast rule. And the cast rule tells which ratio is positive. And then all the other ones will be negative in that quadrant. This is a very important concept. I will review this concept to make sure that everybody does understand it. Here's kind of an important statement. If you're using your calculator to find an angle, if the ratio is positive, it's always going to give you the reference angle. And I'll show you what I mean by that as we go through questions. So there's your boxable item there of your trig ratios, cosine, x over r, sine, y over r, tan, y over x. Now make sure you highlight this next part. The primary trig ratios in quadrants 2, 3, and 4 are related to the reference angle from quadrant 1. What we're going to do is we're going to trick the calculator into thinking we're talking about quadrant 1 when we're talking about 2, 3, and 4. All right, let's do one. Point, -2, -4. First step, draw it. Always find out where is -2, -4. Plot it, connect your dot, and I'll always recommend make a triangle. You don't need to make the triangle, but I'm going to recommend you make the triangle there. And label the sides. We know that that's -2 and that's -4. We need to determine the primary trig ratios of theta. Theta is this distance actually over here. That's what theta is. Standard position starts at the positive x-axis, works all the way around. So if we're going to do SOHCAHTOA, the sine of theta is equal to, and sine we just saw was y over r. So let's figure out our x values, our y values, and our r values. We know that x was -2. We know that y was -4. We got to figure out the r value. So that's where it walks in. R squared equals x squared plus y squared. Pythagorean theorem there. R squared is equal to -2 in brackets squared plus -4 in brackets squared. So r squared is equal to 4 plus 16. R squared is equal to 20. R is equal to the square root of 20. Now last year we did some reducing of radicals. So we're going to reduce this. Square root of 20, not in lowest terms. We're going to reduce that. I can take 20, break it down into the square root of 4 times 5. So that gives me the square root of 4 times the square root of 5. Square root of 4, oh, that's a perfect square. That's 2. Square root of 5 stays as such. 2 root 5, that's what I'm going to use for r. Now I can use those three and deal with my sine. Sine is y over r. Y was -4. R, 2 over root 5. Take it down to lowest terms. I can divide a 2 out of each of them. So that's going to leave me with -2 over 5. Cosine. Cosine of theta is equal to x over r. The x is -2. The r is 2 root 5. Hey, I can reduce that. Those divide down. So we get left with -1 over root 5. Tangent. Tan is y over x. So we just plug it in. Y over the x. Take it down to lowest terms. -4 divided by -2, that's +2. And we've got that one done. The trickier part here is finding the angle to the nearest degree. Because if you just use the sine, the cosine, or the tan, you actually will get slightly different answers from each of them if you just do it as such. Because the calculator doesn't know exactly what you want it to do. And it can't do the thinking. So here's what we've got so far. We've got the sine is equal to -2 over 5. But let's go back to that cast rule. We're saying that the sine is negative. Well, where is the sine negative from the cast rule? Well, sine is positive in all and positive in the sine. So that means sine is negative here or there. I don't know which one of the two I'm talking about. The calculator doesn't know which one of the two you're talking about. So when you punch it into the calculator, it's going to give you the closest one to the x-axis, which is actually going to be that one. And that's not what we're looking for. If we go to cosine, again using our cast rule, do the same thing. Cosine is positive in C and A, so that means it's going to be negative in the other two. And again, it doesn't know which one of the two that you're talking about, so it's going to take the closest one to the positive x-axis there, it's going to take that one instead. But that's not the one we're talking about. If we look at the tangent, again, we've got CAST. We've got the tan being positive. Tan is going to be positive here, and it's going to be positive there. Calculator is only programmed with the closest one. Calculator is going to think you're talking about this one, but that's not the one we're talking about. So each one of them actually give you a wrong answer. So we've got to do the thinking, not the calculator. This is where it gets a bit tricky. And I'll give you some rules of how to deal with it. This is where the reference angle comes into play. We need to find our reference angle. The reference angle is going to be what's inside the triangle here. If we can find out what's inside that triangle, then we can do the thinking and apply the rule that we were given to get the principal angle, which is that green part there. So the first thing we're going to want to do is trick the calculator into thinking we're talking about quadrant 1. In quadrant 1, there we go, all of our ratios are positive. So what we're going to do is we're going to take every one of these ratios here, and we can choose any one that we want, make it positive. Hey, the tan one's already positive. I'm going to use that one. So the reference angle is equal to the inverse tan of 2. This is not my answer. This is just the reference angle inside of the triangle. Punch that into the calculator, and we're going to get 63.4349 ... So we're going to use approximately 63. That means inside the triangle is 63 degrees. But I've got 180 all the way to here, plus an extra 63. So my principal angle, the angle I'm actually going to be looking for, which we're going to call theta in here. I don't have to say principal angle. I can say the theta is equal to 180 degrees plus the 63 degrees that I had from there. And that gives me 243 degrees all the way here. I'm going to jump over these next two charts. I'm going to discuss those in class. And I'm going to go right into question number 2 now. All right, we're looking for all of the angles that have a reference angle of 30 degrees. Let's draw those on here. First one, quadrant 1, quadrant 2, quadrant 3, quadrant 4. 30 degrees in here, 30 degrees there, 30 degrees there, 30 degrees there. Better put my degree sign. 30 degrees. We had a special triangle that talks about 30 degrees. I'm going to write it down up here for you. If that's 30 degrees, that's 60 degrees. We had 2 here. Next to the 30 degrees was root 3, and opposite was 1. So I can start labeling all the sides here. Square root of 3, 1, 2. The hypotenuse, the radius of the circles, is always 2. Now the root 3 and the 1 can be positive or negative depending on which direction we're going. When we start going into quadrant 2, we're going into the negative direction there. So this is going to be negative root 3. We're going up, so that's a positive 1. This one we're going down, so that's a negative 1. Over here we're going down, that's a negative 1. Now we've got all of our side lengths labeled. I'm going to put points up on each corner. I went root 3, comma 1. This one I went negative root 3, comma 1. This one I went negative root 3, negative 1. And this one root 3 and negative 1. In quadrant 1, reference angle is 30, principal angle is 30. In quadrant 2, my reference angle is 30 degrees, but I need to calculate my principal angle. It's 180 minus the 30, which gives me 150 degrees. In quadrant 3, we're 180 plus the 30 degrees. So that means we're 210 degrees. And in quadrant 4, we're 360 minus the 30 degrees. And that gives us 330 degrees. Let's start doing them. Sine of 30 degrees, cos of 30 degrees, tan of 30 degrees. Sine, y over r, 1 over 2. Cosine, x over r, root 3 over 2. Tan, y over x, 1 over root 3. Those ones are done. Now we go to 150. So we got sine of 150. We've got cos of 150. We've got tan of 150 degrees. And we read it straight off of there. Again, it's going to be exactly the same as what we have in the black there in the 30 degrees, but the positive and negatives are going to change for some of them. We can figure them out again using that cast rule. We look at them there and we say, we've got sine, y over r, that's 1 over 2. Cosine, x over r, that's negative root 3 over 2. Tan, 1 over negative root 3, which is negative 1 over root 3. Cast rule said that sine is the only thing that should be positive here. And it is. So we can use the cast rule to carry on down into the other answers. You could also go through the whole thing and look at the triangles. But if we go to quadrant 3, sine of 210 degrees, cos of 210, tan of 210, we're going to have the 1/2, we're going to have the root 3 over 2, and we're going to have 1 over root 3. But we've got to look at which one's going to be positive only. The only one that's going to be positive is the tangent. So that means the other two have got to be negative. And if you did the work from there, you would find out that that's true. Last one, 330. So we've got the sine of 330. We've got cos. And we've got tan. Again, going to be the same. 1/2, root 3 over 2, and 1 over root 3. Looking at which one should be positive. The only one that's going to be positive is C. The other two, got to be negative. Done. Most questions are not going to ask you all of this. That's a lot to ask. They're going to be more like the next question. So question number 3. To the nearest degree, which values of theta satisfy this equation? Tan is negative 4/3. We've got to use that cast rule. So we're going to start by drawing. So step 1, sketch it. So I'm going to sketch. I know using the cast rule that tan is negative in quadrants 2 and 4. So I'm going to draw one here and one there. I don't know which one we're talking about. It could be negative 4 over 3, or it could be 4 over negative 3. I don't know which one I'm talking about. So there's going to be 2 answers. That's step number 1. I sketch using cast rule. Step number 2. Find reference angle. We find the reference angle by going the inverse tan of the positive value. Notice that? That's not a mistake. It is the positive value here. The positive or negative just told us where to draw it. The value now is what we're going to use. We're going to trick the calculator into thinking we're talking about quadrant 1. And we'll find the reference angle inside, and that will be the same reference angle in the other two sides. Punch that into our calculator. We get approximately 53 degrees. That means 53 degrees inside here, 53 degrees inside there. Step number 3. Step number 3, we're going to solve for theta. The way we're going to do that is we've got two answers, a quadrant 2 and a quadrant, 4. In quadrant 2, we've got 180 minus 53. In quadrant 4, we've got 360 minus 53. Doing the quick math on that, we've got 127 degrees and 307 degrees. Those are the two answers that we need to write down. All right, bringing the last one together here. We've got cosine theta being negative 4 over 5. We know that cosine is x over r, and r must always be positive. So therefore, x is equal to negative 4, r is equal to 5. The r must always be positive. Let's do a quick sketch. Cosine is negative, C-A-S-T. So cosine is negative in these two quadrants there. That's negative 4. That's 5. That's 5. We need to find our y value so we can find the rest of the ratios. Same as we've always done. Y squared equals r squared minus x squared. So y squared equals 5 squared minus, in brackets, negative 4 squared. Should bracket that one as well. 25 minus 16. Y squared is equal to 9, so therefore y is equal to 3. And it could be plus or minus when we take the square root. Because we've got a plus 3 going up, we've got a minus 3 going down. We've got two places there. We've already got cosine, so we just need the tan of our first one in quadrant 2. We've got tan of alpha. They changed it up. It's not theta this time. That's going to be, oh, and we also got the sine of alpha. Tan is y over x, so we've got negative 3 over 4. And we've got, in quadrant 2, the sine, y over the r. We've got 3 over 5. Then we got quadrant 3. We do the same thing. We've got a tan, and we've got a sine. Tan in this case is going to be positive 3 over 4 because we've got a negative over a negative. And then we've got sine, which is going to be negative 3 over 5. Last thing, to find the angles, we're going to use the exact same thing we did in number 3. The 3 steps. We've got it drawn, so that's step 1. Step 2, reference angle. Reference angle is equal to the inverse cos of the positive value. Always the positive value. Trick in the calculator. Again, star that positive value. And then we can punch that into the calculator. It comes out to approximately 36.86. So we're going to say 37 degrees. Then we've got step number 3. Solve for our alpha. We've got a quadrant 2 and a quadrant 3 answer. In quadrant 2, again, 180 minus that reference angle. 180 minus the 37. And in quadrant 3, 180 plus the 37. Two answers are going to be 143 degrees and 217 degrees. Done deal. That's the answer. Hey, finish off with your discuss the ideas. Bring this information together. It's a tricky topic when you're first starting. I know that. So do these ones and your think furthers that are in through the sides. We'll discuss those. We'll bring it together. I will be re-explaining most of these concepts again because I know they're tricky and they're extremely important. Have a good one.